So today's discussion is based on understanding a Unix shell script. A shell script is a collection of Unix commands with some decision or control statements and iterative actions, if any, with some logical flow to its execution. Which helps you in accomplishing a given task in hand. So what is a shell script necessarily? It's a collection of Unix commands. But I cannot normally put some random discrete commands in a shell script. What is the purpose of a shell script? The purpose of a shell script is to accomplish a given task in hand. I want to accomplish something. Taking a backup of one file into a user specified location is one of the activities. So I cannot write some random commands like pwd, hostname. They are irrelevant for the given task in hand. So necessarily a shell script is a collection of Unix commands. It may have some decision or control statements, like I said, if then else, condition, evaluation, whatever statements, and it may also have some iterative actions. Depending upon my requirement, I may want to do the same activity repeatedly as long as there are records available in a file. So I am doing the same action. How long? As long as there are records available in the file. So iterative actions, if any, with some logical flow to its execution. So we don't type randomly any number of Unix commands in a shell script. There has to be a logical flow. So accept name, accept age, then decision making. If age is less than 18 years, then you are not eligible for voting. If age is greater than or equal to 18 years, then you are eligible for voting. So this is a decision making structure. Do it until as long as there are records available in my voters file. So iterative action, which has some logical flow, which helps you to accomplish a given task in hand, is what we mean by a shell script. It's not mandatory, but it's a common convention that the first line in your shell script should begin with a shell directive. This is called as a shell directive. The first line that identifies for which shell. We know there are multiple shells now. There is a Bourne shell, there is a corn shell, there is a C shell, there is a bash shell, there is ZSH, TSH, JSH. There are too many shells available. Now when I said this is my shell script, the first line should identify, although it's not mandatory, the first line should identify for which type of a shell below instructions are written for. If I don't identify this, then whatever is my command shell, your command shell may be bash in Linux, it may be corn in case of other Unixes. So that particular shell's copy will be used to execute your instructions. Now consider a case that certain commands that I use are very shell specific. Like we have noticed one cd command, cd with a hyphen. Does it works with a bash? No, it only works with a corn shell. Similar way, there is a arithmetic expression evaluation where we say sum is equal to a plus b. So this type of a expression in case of a Bourne shell and in a bash shell is written in a different way than it is written in a corn shell. So assume a case that I have written a shell script to accept two numbers from the user and to display the summation of it. And I have written instructions which are very corn specific. I didn't mention on the first line for which shell these below instructions are meant for, and my command shell was bash. So since I didn't mention a shell for the below instructions, what will happen when I run this shell script? It will examine what is my command shell. My command shell is bash. It will make a copy of bash, and in that copy it will run my instructions. Now my instructions are very corn specific, corn shell specific. Obviously my shell script will error out. But people say, what if I am writing generic instructions which can be run in any shell script? Then obviously the script will not complain. So you are not sure about which are very generic instructions and which are very specific to a shell. So as a standard practice, because I can't come to your workplace and ask you to display me your shell script so that I can evaluate. At least in the lab life, your shell script must mandatorily start with a best practice saying hash exclamation bin ksh or hash exclamation bin sh or hash exclamation bin csh or hash exclamation bin bash. Without this, I don't want to see anybody's shell script. In real life, what you do is your own prerogative. But as a standard practice in the lab, you must execute it with a shell directive. The first line should always be, for which shell I have written these commands. I told you this is not mandatory, but this helps somebody. So if some programmer has written a shell script, I don't know who has written it 4 years down the line. I am the one who is supporting the system, and my shell script is nowadays erroring out. My program manager says, go and debug this script. Now I am clueless for which shell these instructions were meant for. So my job as somebody who is supposed to troubleshoot that script becomes extremely difficult, because I need to read the entire shell script to identify, are these instructions pretty generic? Are there any instruction which are very corn shell specific, bash shell specific? Otherwise, whatever is my default shell, the default shell will be used for my script execution, which may or may not work, which makes my job extremely difficult. So the first line should always be the shell identification directive. So hash exclamation bin ksh is a shell directive which indicates the type of the shell to be used for interpreting the instructions given in the shell script. So very important concept. You can also add appropriate comments wherever possible. Any line which either begins with a hash or on any line where an hash comes. So it need not necessarily begin with a hash. On whatever line, if you put a hash, and whatever follows after that hash will be treated as a comment. A comment makes a program readable. So comments are not mandatory. Comments are anyways ignored by the shell, which is your command interpreter. So comments are always ignored. Then why to put a shell? Why to put a comment in a shell script? A comment in a shell script makes your shell script readable. Now assume a case, I have not written this highlighted line. This is not there in my shell script, let's say. I directly have a generic instruction which says var avg sal equal to var total sal divided by var emp count. Now it is very easy for me to interpret it now because the variable names are quite self-explanatory. But consider a case, a general programming that we do as a student. We say z is equal to a by b. Now tell me, what is z is equal to a by b? It doesn't tell me anything. Well, then I am telling you, I am a programmer, I have written this, so I know you can't understand this thing. Z is average sal, A is total salary, and B is employee count. So you know what I am doing here? I am counting the average salary. So don't write a shell script. My father used to call it, looking at my handwriting, कि तेरा handwriting ऐसा है कि आप लिखे खुदा बाचे. So don't write a shell script which gives a brain tumor to the reader. This gives me a brain tumor. Variable names can be as long as 255 characters. So use the full length. Make your variable readable. Now tell me which you think is a better way for me to read. Variable average salary is equal to variable total salary divided by variable employee count. Is this better, or Z is equal to A by B is better? Okay. Now that you have all accepted that the above one is better, going forward, if I see a shell script which says Z is equal to A by B, it will be rejected on the same day, and you are not supposed to attend the classroom from the second day. It's very simple. So then don't make that somebody to go for a brain tumor operation. Your variables can be up to 255 characters. Use a more explanatory variable name. So the job of the person trying to understand it becomes very easy. Remember, it's not a riddle. You are not putting a riddle for him. तुम्ही त्याला काही कोडं टाकत नाही आहे की बघ आता वाचून दाखव बेटा आता काय आहे ते. So don't do it this way. Plus, an appropriate comment is very important. See here, below line calculates the average salary by considering the total salary paid divided by employee count. Now with this one, the line becomes even more readable. So I know what is the programming logic that has gone through the shell script. Whatever the programmer has put in, it's more clear to me. Even when I do not understand where AVG sal and where total sal and where EMP count. Because most of the times, given that we are bilingual people here in India, our mother tongue is English and the other foreign language is Marathi or Hindi, isn't it? So that makes our life even more difficult, because what is this? I don't know. What is that I have typed? That's why I said your mother tongue is English and your secondary language is either Marathi or Hindi. I would have called it as Sale, which makes our life very difficult. So at least we the Indian people must introduce appropriate comments. What Britishers do, what US people do, I don't care. But we as a programmer, we must introduce proper comments here. So it's not Sale itself. Clear? So very simple. So try to introduce comments. Comments can either be introduced at the beginning of the line or somewhere in between. Like something like, I would have introduced a comment saying, something like this. So on the same line where my program instructions are written, down after, immediately on the same line, I said hash followed by whatever I want to write. So comment need not start with a hash sign on a new line. It can start anywhere on the line. But one thing is for sure, after there is a hash, whatever you write then will be treated as a comment. So people say, can't I introduce a comment in between? No. You can't introduce a comment in between like sum is equal to A plus B hash and don't expect then product equal to A into B. On the same line, it's of no use now. The moment it encounters a hash, anything that follows until the end of the line will be treated as a comment. If you want to put an executable instructions now, it should be on a separate line. So if I want to do a product, I should have done it like this, followed by a comment again. So the moment a hash mark is encountered on a line, whatever follows until the end of the line will be treated as a comment. So very important. Introduce appropriate comments. Use more logical and readable variable names and program names. This is often one problem I have noticed in the lab life, that people, they do not use appropriate names for either the variables or for the program. I have given an assignment for people and then they start attempting it, and then they said 1.sh, 2.sh, 3.sh, 4.sh. I said, show me your shell script where I asked you to do a loop, and then they said, I don't remember which is either 1.sh, 2.sh, 3. Let me see. Vi, all of them, and then find, this is the one, 3.sh. So use appropriate program names. The program name should tell you what is the program meant for. If it is for, if it's a program for while loop practice, then my program name tell me which is better. Is this better or 3.sh is better? Second one is better. Now even when you know this, why you use 1.sh, 2.sh, my.sh, your.sh, his.sh, her.sh? God knows what you are writing there in the shell script. It's not clear to me. But if I look at this one, I know for sure that means the programmer is trying to do a while loop test. Isn't it? Is better than 3.sh. So write more lengthy and purposeful names instead of writing some cryptographic names. Those cryptographic names are one who himself does not understand couple of days down the line. Is what is called as a crypto name. So don't use crypto names. Use more logical and readable variable names and program names. Now consider a case. This is a sample decision making structure where I said if $x is equal to 18, then you are not a miner. Now tell me what is $x. What could, with respect to this particular highlighted section only, tell me what is $age, $x. Its age. Now tell me, is it good to call it $x or is it good to call it as a age of the person? So you know already which one is better, right? So why $x is not appropriate here? Will my compiler, will my shell interpreter complain about this thing? It will not complain. It's technically correct. But which is more readable of the two? Age of the person, if it is equal to 18, then print a message that you are not a miner. Is this better or $x is equal to 18? You are not a miner. Which one is better? Second one is better. So your variable name should itself be self-explanatory. Now I don't know what is $x. I really do not know what is $x. Because in one program your X is age, in another program the same X is salary of the person. So there should be appropriate comments. There should be appropriate variable names that you use. And although it's not mandatory to introduce the shell directive as the first line, you must still put the first line as for which shell the below instructions are meant for. What was the assumption by the programmer? That which shell would be used to interpret the below instruction. In the absence of it, if I use cd minus, which is very corn specific, and then I try to run it using a bash shell, obviously my program will error out, although there is nothing wrong from the programming side. The only mistake my programmer made is that he never indicated for which shell those below instructions were meant for. If he would have written KSH was the shell script for which the below instructions would have written or were written, then I would have never run into an issue that it gives me a syntax error saying cd command not found or this particular syntax is not known to my shell script. So very important. Another programming standard best practices is a program must exit with some exit status, like the way standard commands exit. Your standard commands always exit with some exit status. So if the command was successful, then it exits with a value 0, which you can further check by saying echo $, which prints you the exit status. Whereas whenever there is an assertion failure or whenever the command itself fails to execute, you return a non-zero value for it, for a general command. The same should be employed in your shell script also then. Consider a case. I said the first line hash exclamation bin ksh, which is a shell directive. I said echo enter a number greater than 10. Then I am reading the input in the variable var num. Then I said, if this number is greater than 10, you entered it right. Should be the message that should be printed. And how should my shell script exit? Exit 0. Because this is a successful execution. Now I am talking about an assertion failure. So if he does not enter a number greater than 10, then I am saying it's a wrong input. Well, if I do not type this line, then my shell script will still exit with a value 0. Now is this correct? Logically speaking, this is not correct. If the assertion has failed or the command's execution has failed, your program should have exited with some other code other than 0. So I am trying to write it now. So understand, what if I comment it? So consider this case. And you must use proper indentation in your program. I am putting a comment here. I am putting a comment here. So in either cases, my shell script will anyways finish. But it will not finish by running the line exit. It will finish in its due course. Now see what happens if I run this shell script. I must mark it as executable file first. Because if I don't mark it as executable, by default Unix treats a regular file as a non-executable one. So I won't be able to run it. It says permission denied because there is no executable bit set on this file. So I am marking it as executable first, followed by running the script. It says enter a number greater than 10. I said 12. It says you entered right. If I type now echo $question mark, it was a successful execution, which is how it is supposed to do. Now I am running it one more time. It says enter a number greater than 10. I entered 3. It says wrong input. If I say echo $question mark, see what it says. Is this correct now? This is not correct. If my command or command's assertion has failed, appropriate exit status should be given back to my calling shell. Calling shell in my case is my parent shell bash, which is my also command shell where I type the commands. I am editing my program one more time. I am removing the hash and I am rerunning it now. I said it says enter a number greater than 10. I deliberately entered 3. It says wrong input. If I say this one, now see what it says. Now this is more appropriate now, which indicates the previous command that I ran. Which command I ran? Exit underscore status.sh has failed either in the execution or in the assertion. And that's why it is coming out of the program control with a exit status other than 0. If you do not put an exit command in the shell script, even after branching from if, loops, whatever, it will always come out with the exit status as 0, which we don't want. So come out from a program with a proper exit status, because sometimes I may not be interested in the output. I may be only interested in checking whether my command ran successfully or not. Consider this case. I am not interested in the output. And further I said echo the command was successful, else echo the command failed. I am not interested in the output. I am only interested in the exit status. Remember the conditional execution, double ampersand and double pipe operator. Whatever command is with a double ampersand second in the queue, it will run only when the previous one was successful. Whatever follows after a double pipe would only run when the previous has failed. So when I run this, if it prompts me for something, I am entering this thing. See what it says? The command has failed. If I run this, if I type a number 12, the command was successful. So it's not printing something from the standard output. It's printing me, it's not printing me the standard output. Instead, I am making a decision on the basis of the exit status. If I remove the exit status, it will always give me the command was successful. So if I edit my shell script now, and if I comment again these lines, and I run it again, I say 3, see what it says? The command was successful, which is not the case, right? The command has failed in this case. So since my shell script has no exit conditions given, whatever is the default exit status 0 after executing all the instructions will be given back to my parent or calling shell, which in my case is a bash, and it says depending upon the exit status 0, it says the command was successful, which is not the case in this in this execution though. So very important for you to come out from a shell script with a proper exit status, so that if somebody wants to make a decision on the basis of whether your command ran successfully or not, he should be able to do one if there is a proper exit status. Now whatever you write in a shell script after the exit command will never be visited. See here. In both the cases I said one more line after exit, print this line. See what happens when I run it. Did it print? Did it print? So anything that follows after exit will never be even looked up, because my shell script terminates the very moment the exit command is encountered. Nothing after that will be executed. Now don't be misled by what I mean. So the moment exit was encountered, anything that follows will never be executed. So people say, then how come it executed the else when there was an exit here? Because the condition never tested as true when I put the input as 3. So it says, is 3 greater than 10? No. So it never went here. It instead went here. It then printed wrong input. Then it came out with the exit status as 1. The moment it encountered exit command in the shell script, it never even attempted the other remaining commands in the shell script. Clear? So the moment an exit is encountered, nothing further in the shell script will be even looked at. So it will not even look at the other things in my shell script. So I am saying, after this I said echo last line in my program. See, nothing. The moment an exit was encountered, everything that follows thereafter was all ignored. My shell script terminated the very moment there was an exit instruction. I am deliberately trying to commit a mistake in my program. Remember, the instruction that I typed is itself a wrong instruction. It says $x hyphen GT should be the correct operator, but I use only GT. But it never worried about even there is a typography error in my program, because it never went there to see what is the instruction. The moment it encountered exit, it came out. So this is typography error. It should be the correct operator is hyphen GT, but I only type GT. So that's why the moment it should have complained otherwise, right? But remember, it acts as a interpreter, not as a compiler. Your shell acts as an interpreter. So it only considers the current line that you are trying to execute at a time. It never goes through the entire program, then checks is this syntactically correct, and only when it is syntactically correct, then it starts executing as a second pass, line by line, procedural logic that I have written in my shell script. So this is an interpreter. So it reads only one line at a time. It runs it on your screen. It went here, either this exit or this exit was encountered. It never has to even bother about what is there after this. So as an interpreter, it never bothered about what is there in my program down under. It simply ignored it the moment it encountered the exit symbol. Now let's talk about comparison operators. So I'm going to talk about now comparison operators, because decision making is not possible without you using some kind of one or other type of a comparison operator. Before I do that, let's read this out. I said the first line is always the shell directive. I said enter a string. I accepted that input in var string 1. So this read command is as good as scanf statement in C programming. That scanf reads a particular data input from the keyboard and then it assigns it to some variable. The same way a read, whatever is being provided from the standard input, it would read it from standard input and it terminates when a new line is encountered. So that's why if I write a simple instruction, I'm running this script now. It simply accepts a name and then prints a welcome message. Nothing great. So I'm running it now. It says enter your name and it's waiting for my input C. So what is that it has executed from my program? As of now, it has executed the echo statement. Echo statement was enter your name. Now it is waiting for my input. What is the input? Why it is waiting for my input? Because it encountered the next instruction, read in var name. So it's waiting for me to type something from the standard input device, which is keyboard. And it will wait until how long? Until I press enter. Because a read terminates with an enter. So I am typing my name. This is my long running name. It's still waiting. And is even longer than the longest name in any country. You won't find such a name anywhere. I am now almost tired of typing my long name. It will keep on reading. How long? Until I press a enter. Now I press an enter. See what it says. This is my long running name and is even longer than the longest in any country. You won't find such a name anywhere. I am now almost tired of typing my long name. Welcome to the Unix world. Clear? So understand, read terminates with a new line. So understand the program instructions one more time. So it was waiting for me to provide the input. Could be of any number of lines, provided there isn't any new line character. The moment a new line was encountered, read terminates. Then it starts running the next one. So I said, what is the variable name here? Var name, which is where I accepted the input. And then I said dollar followed by a variable name which prints the value of the variable. So understand this. When I say x equal to 10, so I have done variable equal to value. If I say echo x, it simply prints me x. What is that you wanted to do? Value of the variable x, then you must say $x. If I simply say echo x, it will print x on my screen. If I say $x, that dollar means print the value of the variable x. Then I said echo $z. Remember, there is no such variable that I defined z. So it prints me null. That means the variable has not been defined or has not been assigned any value. We talk about this as an initialization of a variable, which means the variable hasn't been initialized yet or hasn't been defined. So understand the way variable works in Unix. Remember, in Unix, the variables do not have a data type associated with it. They are more loosely typed. Means all variables by default are treated as text. What I mean by this? I said x equal to 10, y is equal to 5, and then if I say echo $x plus $y, don't expect it to print the arithmetic of it. See what it says? Actually, it should have printed 15. This is not the case because by default x was assumed to be a text, y was assumed to be a text, and when I say some text plus some text, it will print this plus this. If you wanted to tell Unix that this is not text, then your input should accordingly be. So I wanted to say, oh, this is not text. Then I must ask Unix to do an arithmetic expression. See what it says now. So what I asked Unix to do? Arithmetic expression. So I said perform an arithmetic expression assuming x is a number, y is a number, and then display an addition of x and y. This is why it prints me 15. So understand this one more thing which is new for us in Unix. Unix does not have variables or rather data types associated with a variable. All variables by default are of the type text. When you think no, this is not a text, it's indeed a number, then you must indicate it in your operation saying by doing an expression command. Expr is a command. An expression command, if I put it like this, see what it says. Clear? So I use the command expression followed by some arithmetic expression of your choice saying put the value of variable x, which is 10, put the value of variable y, which is 5, and then 10 plus 5 perform an arithmetic expression of this thing. Clear? Which prints me then 15. In the absence of arithmetic expression, since both the variables are treated as text by default, it would have printed me 10 plus 5. Clear? Now people say, what if I do not assign a numeric value to variable x? Then obviously simply putting an expr command won't convert it to numbers and won't do a miracle for you. Say for example, if I say x equal to pu and y is equal to ne, then don't say expression $x plus $y would print me Pune. Some of the people, they are good thinkers. They say, oh, does it mean it will print MH12 now? Clear? So see what it says. It says a non-numeric argument, because you are trying to perform an arithmetic expression where $x value is pu and $y's value is ne. So you can't ask in any mathematical convention pu plus ne is equal to what. So it will result into an arithmetic expression error which says a non-numeric argument. So obviously don't expect it to perform anything for you in this case. First, the value should be convertible to a numeric equivalent. Like in the previous case, x is equal to 10. That 10 was actually a text. Textual 10. But that textual 10 can be converted to its numeric equivalent number 10. So it has automatically performed that conversion for you, and on top of that it performed the arithmetic expression of number 10 plus number 5, which results into an arithmetic summation 15. But in this case the value of variable x is pu, value of variable y is ne. So don't expect it to do any miracle for you now. Clear? So the values themselves should be convertible to numeric one if they are even by default text by its very definition. By its very definition, all values that you assign are textual until and unless you say otherwise, saying this is a numeric value. So I said enter a string, read the value, enter another string, read it in some other variable, var string 1 and var string 2. Then I am comparing, is the first string equal to second string, then display a message they are equal, otherwise display a message saying they are not equal. A very simple decision making construct. Now the operator that I use for comparison is a equal to operator, but it's not the same everywhere. For numeric comparison, the operators are different. For string comparison, the operators are different. You will come to know once we go a little further. Before that, let's understand how to do a simple decision making in a program. A simple if is written by saying if in square bracket. Remember, the square brackets are part of syntax and does not indicate optional input. Normally up till now we use square bracket to include in a command the options which themselves were optional. Here the square bracket is part of the syntax and often you have to leave a space. So square bracket, space, condition, space followed by a square bracket. This is how syntactically if is written or any condition evaluation statement is written in case of shell script. Then followed by action statements followed by fi. Now when would these action statements be run? Only when the condition evaluates to true. Only then these action statements would be run. If I say simple if with otherwise action, see how it works. If condition, then perform primary action. So only when this condition evaluates to true, run these statements. What if the condition is not true? Then run this portion, the otherwise action. So if this is not true, then it would run the otherwise actions. What if it's a complex if with or for multiple condition evaluation? With a complex if, I can also evaluate for multiple conditions. You say if this, then do this. Else if this is the condition, then do this. Else if this is the condition, then do this. Else, when none of the above, then perform this. So it's a complex decision making structure with multiple if, else if statement. Although you don't write else if as ELSEIF, you need to write it as ELIF. ELIF is the way to write else if in case of a shell script. You could also write a nested if by saying if condition then outer action statements. Within this if, I am writing one more if. If further this is condition evaluates to true, then perform the inner action statements also. Remember, every time you write an if, it ends with an fi. So in case of a classic C language, you would have written if condition start of action, end of action. Isn't it? So start of action and end of action. In some other programming language, probably you could have written end if. In case of C, in case of Unix, it always ends with a fi, which is if ka exact reverse, fi. Now if somebody wants to write a condition, then you must understand the way a condition is written. You can typically a condition is like operand 1 followed by some operator followed by operand 2. Example, if $x, which is operand 1, comparison operator is eq equal to second operand 2 in my case is $y. This is how you write binary test conditions. a binary test condition has two operands. Operands is something that you apply operator to. So this is called as an operand 1 followed by some decision making operator or a comparison operator and followed by some second operand. So it's this type of a decision making condition writing is called as a binary condition. Then sometimes it may not be binary, it may be unary only. For example, operator followed by operand. Example, -f followed by file name. That -f comparison operator checks if the file exists, then return true, else returns false. So what I am doing, what is this? Operator. What is this? Operand. How many operand are required in this case? Only one. How many operators are required in this case? Only one. Such a condition is called as a unary condition. Clear? Whereas this one was a binary condition. Now before I should be in a position to write conditions, I must understand what are the operators supported in Unix shell script. Typically in any other programming language it would have been equal to, not equal to, greater than, less than, greater than equal to, less than equal to. These are typically the comparison operators. However, in shell script it's somewhat different. Now when I say somewhat different, means there are a separate set of operators for string comparison and separate set of operators for numeric comparison. So see here, if someone wants to do a comparison between string values, text values, then you can say string 1 equal to string 2. What will happen? If this is the way I have written my condition, then it would return true if string 1 equals to string 2. What type of a comparison is this? Binary, because it involves how many operands? 2. I would have said string 2 not equal to string 1 or string 1 not equal to string 2. It will return true if string 1 is not equal to string 2. What type of a condition is this? Binary. -z str1. It returns true if str1 is null, not initialized yet, have a missing value. What type of a test is this? Because it has only one operand. -n followed by string name returns true if string 1 is not null. What was the case here? It returns true if it is null. -n returns true if it is not null. Again, what type of a comparison is this? It's a unary test because it involves only one operator and one operand. Whereas in case of binary, there would be always two operands with one operator in between. So these are the operators for string comparison. Now let's understand the way numeric comparisons are performed. You say num1 eq num2. Now where num1 is nothing but a number, you have to substitute it with a number. If it's a variable, then you must put a $, because you don't want to consider the variable name, you want to consider the value of the variable, and wherever it's value of the variable, you must prefix it with a $. So I am assuming these are actually some valid numbers that you are putting here. This is not a variable name. If it would have been a variable name, then you should have put a $. So when you want to check two numbers for equality, you say number 1 eq number 2. So remember, here it was equal to, here it is eq. That eq tells to perform a numeric comparison. Here it was not equal to, exclamation equal to. Here it is any for not equal to. LT is for less than. LE is for less than equal to. GT is for greater than, and GE is for greater than equal to. So numeric comparisons are done differently than text or string comparisons in case of Unix shell script. So always bear this in mind, because until you get a good hang of the operators that you have in shell script, you will be never in a position to make a decision, because decisions are made on the basis of conditions, and conditions may either be binary or unary, but either binary or unary, it still requires some operator, and this is what is required for comparison operators. Then there are some file comparison operators, which is very unique to shell script. You won't find these file comparison operators in any other programming language. So see here, I said -f followed by some file name returns true if the file exists. If the file that you have mentioned here, if that file is really there, the path is correct, the file is there, then it will return you true. -r followed by file name returns true if the file is readable. -w followed by file name returns true if the file is writable. That means you, whosoever is running the program, has a write permission on the file, then it would return true. -x followed by file name returns true if the file is executable. -d followed by file name returns true if the file is a directory. -L followed by file name returns true if the file is a symbolic link. File1 nt file2 returns true if file1 is newer than file2. By newer than I mean depending upon the last modification timestamp. File1 ot file2 returns true if file1 is older than file2. -s followed by file name returns true if the file is greater than 0 bytes. File1 ef file2 returns true if file1 is linked to file2. Link means with an ln command, either a hard link or a soft link. So if it's a link to the file, then it will return true. That file1 is actually linked to file2. Means one of them has to be a link, another one has to be a original file. Doesn't matter whether it's file1 which is a link or file2 which is a link. Doesn't matter if it is a file1 which is the original file or file2 is the original file. As long as one is linking other, it will return you a value as true. Else it would return as false. So you need to get a good hang of all these operators. Now coming back to a simple echo technique. The first line should always be the shell directive, I said, as a best practices. I said echo enter your name. I said read var name. Then I am saying echo your input was followed by the value of the variable. So very simple shell script. I said mark it as executable before I run it, and then I am running it by saying /echo and read.sh. See the problem. It prints a message but goes on a new line to accept my input. That is because echo, whatever you write inside echo, there is always a /n at the end. That /n forces a new line. Actually, ideally I would have liked to input it on the same line. Then I said, so what I want, I should be able to type it here itself. So I am now modifying it. I added -n. See what it says. See what is the difference now, where it is accepting now. On the same line where echo is. So what is the difference? The difference is without a -n, it would print a new line character after whatever you printed. With a -n, it will chop off that new line. You will understand it more clearly if I say See what happened? With each echo there was a new line character. Now if I edit the same shell script and instead add -n, see what happens now if I run it. So the new line after each echo was removed. That's why everything got printed including the next command prompt on the same line. Clear? So if you want to accept the input on the same line, whatever message you print, print it with a -n. Now again echo and read. This is typically another case where you would like to hide the input. I said it says enter your name. I said it says enter your password. See what is the problem with this one? Whatever password I type is being echoed on the screen as is. Is this the way you type a password? Normally password fields are masked with some character. And then when I say enter, it says this was your input. Typically, I don't want to reveal the passwords. If somebody is typing a sensitive information, I would like to mask it. See how I do this time. Before accepting it, I said stty echo followed by stty echo. I am running it. It says enter your user ID, enter your password. So I have entered the password. This time does it display the password? But the confusion is, has it really accepted? See what I typed here then? Clear? I must have typed there secret. So see the way we have concealed the input coming from the standard input device. Whatever you want to conceal, put it in between stty-echo, read the input and re-enable the echo statements. If I want to make it more meaningful because it was not getting displayed properly, then I am running it this time. I have typed my password. See here now what I have typed then. Although it was not displayed on my standard output device as part of the read coming from a standard input device, it was still accepted. So whatever you want to conceal it between stty-echo and re-enable it once you want to display back. So stty-echo suppresses the display coming to standard output device. So what is happening here? It does not display the keystrokes coming to the standard output device. For what? For the read statement that follows. And then I again re-enabled it to the default behavior by saying stty-echo. Whatever I type at stty-echo now again comes back to the screen. Clear? So very important. Echo means do not echo my keystrokes. -echo means suppresses the display, and stty-echo means re-enables the display. So if I type anything going forward, it will be again re-enabled. People say, is it going to be really re-enabled? See it here. See here. Again it was displayed, the keystrokes were enabled. So it says this is your input. So understand the technique. When you want to conceal something as part of input, put the read statement between stty hyphen echo and stty echo. Whatever is after hyphen echo, the keystroke display on the standard output will be suppressed. Minus echo means don't display. Echo means again go back to the default behavior, and the default behavior is whatever follows must be displayed on the screen. It can be used as a general convention on the screen itself. So see here, I said, but I must be really good in typing then. There shouldn't be any typographical error. See what I'm doing? I'm doing really something very secret for you. I said stty hyphen echo. Now whatever I will type, only I would know. So I don't want to commit a mistake. So I will write it, and I'm not very flawless in typing. See what I'm doing now. It's pasted. You are not able to see this. So ghost. I have pasted, and now I am saying Control D. Well, I don't know whether it was done or not done, because still my echo is suppressed. I re-enable it by saying stty echo. I am back to normal. See, whatever I type now I can see. Now what I have done when it was down, I have created a file for you, which I only knew. Clear? So you can use it as a general technique if you don't want people to see what you are doing. So act smart. So display should be disabled, and then do whatever, and then re-enable it. He will never know what you have done. Provided you should be really good in typing, not like mine. Otherwise, don't display. I am doing it in Notepad. This is what I am pasting. What is the use of this thing? So I am assuming I would have typed this command directly on the command prompt where people can't see me what I am doing. Stealth mode. That stealth mode means people can't see you. Well, with this one we conclude today's session, but it won't just happen like this. It must be followed by a lot of shell scripts. So I will put a pause on this one. You can make a note of all the shell scripts.